Hello! We are about to start a unit on chemical equations, or rather continue our chemistry unit with chemical equations. And we kind of talked before when we did bonding. We did one atom and how it would interact with another atom, and we found out that sometimes you can match up one atom here with, say, another kind of atom. I don't know what that is, but say they're bonded together. And we could say that that bond could be covalent if they're sharing an electron, or it could be ionic if they're trading or exchanging. So this would be a bond together, and they will make chemical bonds. And that was about as far as we got, and we found that when you bind two atoms together, you can get a molecule. And one of the molecules we talked about was water, so let's say we had a water molecule. That would be an oxygen. This would be a hydrogen. The hydrogens are a little bit smaller. And I'm just drawing it here. We'd usually draw it like this: O, H, and H. But if I just wanted to kind of sketch out, this would be a molecule of water, and I would call that H2O. And if I had more than one of those, let's say I had another molecule of water over here. Oh, needs to be white. Say I had that one, and I had another one right here. Well, these would still both be H2O. So this H2O, this would be H2O. And since I have two of them, I could say that I have two H2O. And this is a little different than we've done before. Now we have a number of molecules, and this we would call the coefficient. You may remember that from algebra. It's just a number multiplied by a variable. Well, here we're taking a number and we're multiplying it by a molecule. And this is going to help us when we go to write chemical equations. So for example, if we have 4 aluminum atoms, and these come in a solid, you can buy aluminum as a solid, and we combine them with 3 oxygen atoms, which, as you may be breathing in right now, hopefully are. We're basically saying that we have 4 aluminum atoms on this side here. We're taking 4 aluminum atoms and we're combining them with 3 O2 molecules. So these are oxygens bonded together, and actually O2 is it's a covalent bond, double covalent bond. So I'm taking these three oxygen molecules, and I'm going to put them in the presence of 4 aluminum atoms, and I'm going to see what happens. And when I say happens, it's a chemical reaction, and that chemical reaction is denoted or drawn or said with this arrow. If I say that I'm taking these aluminum atoms and I'm going to put them together with these oxygen atoms, well, that's where the plus comes in, putting them together. Then I'm going to use this thing, this arrow, which I read with just the word yields. Yields. So when I put them together, it yields something. Something happens. This is what I get out of it. And then what I get out of it will be on this side. And what I'm putting in here, I'm going to call these the reactants. This is what's reacting. This is what's starting. These are my ingredients, my reactants. And what I'm getting out, I'm going to call my products. And if I know enough about the behavior of atoms and the conditions for bonding, then I can say, without even doing an experiment, although it's more fun to do, if I take 4 aluminums and I put them in the presence of 3 molecules of oxygen, I can predict what will happen. And this chemical equation is a way of noting what we think will happen. And we're going to learn how to do that in this module. I do want to just make a quick note before we finish off here that these little subscripts, these are not the numbers, these are not the molecules, those are already there, the 3 O2s. The solid S, if you see S, that means that whatever you're using is in a solid state. And if you see a G, that means it's in a gaseous or a gas state. You may also see an L, which means it's a liquid. And then the other one that you'll see, and is very common in biology especially, is this AQ. AQ means an aqueous solution. It just means in water. means that it happens when you combine it in water. Okay, so that's kind of the structure of this equation and the formulas that we're going to be working with. Formulas both for the molecules themselves, like O2 is a molecular formula, but then this is the whole chemical equation. Whole chemical equation with the reactants here, and the products coming out of it.